Hey there, it is Saturday afternoon, September 24th, 2016, and in this video, we're going to be talking about potential future Hurricane Matthew and perhaps Major Hurricane Matthew, why I think it will develop, and why we're going to have potentially a very, very big storm on the map in about a week's time. And this right now is going to start off with a quick view of the tropical Atlantic. Up here we have Tropical Storm Karl. That's going northeast and getting out of the picture. Over here we have Elisa with her exposed center, very weak. Both those storms are going out to sea and are not going to pose any threat to land. But the cluster of thunderstorms that we are concerned about is actually this little feature way down on the bottom right-hand corner of your screen. It's barely even visible as it's coming off of the African coast, or came off the African coast yesterday. And it's that cluster of thunderstorms that the models have been hinting at, particularly the GFS for days has been hinting at, is going to become a problem once it reaches the Caribbean. And that's one of four reasons we're going to go into in this video why it is so concerning. So let's jump right in to the models. First of all, the GFS, because this is the model that has really been honing in on this potential feature for days. It's been remarkably consistent. It's shown some sort of major solution in the long range over and over again, to the point where it cannot be ignored, even though it's happening so far in the long range, because it has just been so unbelievably consistent. If this verifies, this is one of the greatest performances of the GFS of all time on a big storm, if it is correct. So here it is at day 3 here, 72 hours out. You see at 500 millibars, this area of vorticity here that is east of the islands here in the Caribbean, about to enter. And I'll just play it forward. You can see this is generally going to become more organized as we go towards day 4 and day 5, until finally we get out here by next Friday, the end of next week, where we have a full-blown hurricane out in the central or the eastern Caribbean. And if we switch our view here to the higher resolution, what you're going to find is you already have a storm down to 972 millibars here on the high-res GFS, which has been showing this for run after run now. And in this run, you can play it forward. It does this every single time. It runs it out, continues to intensify it out towards Jamaica, comes very close, brushes the south coast of Jamaica, and then just becomes a Category 5. It has shown a Category 5, I think, on 6 of the last 7 runs now. But either way, the details are not important. The important thing here is that the consistency of what it is showing in the long end. This is 10 days out, and it's been showing this run after run after run. On this particular run, the storm is going to go into the Yucatan of Mexico and then run across and make another landfall in Mexico. That far out is probably undetermined. You really cannot determine any sort of details. There was a run earlier where it went up into Florida, one went into Louisiana, one went ran up the coast and hit New England a couple days ago. One that even went out to sea that kind of split the gap here between some of the Greater Antilles. So there's tons of solutions on the table, and it's so far out that you really cannot predict anything like that. In fact, the only reason why this is even being discussed in some circles is because you have such unbelievable consistency out to day 10. If you want to talk, I want to show you one of the amazing things with the consistency that I've shown. This right here, this image is the high-res GFS today at 12Z. So this is the afternoon model. This is now 210 hours out, so just about 9 days away. This, now I'm going to go to what it showed at 6Z. So this is the previous run. Almost the same spot. Well, look, now we're 216 hours out. So it's almost the same spot. You want to go back another run before that at 0Z, see what it showed at the same timestamp? Almost in the exact same spot. I mean, you're talking about a major Category 4, maybe Category 5 hurricane that the GFS is putting in almost the exact same spot within a few miles of each other. 9 days out. This is just remarkable consistency from the GFS. Now, the European model had not been favoring a storm in the Caribbean as much the last 2 or 3 days, which kind of made you wary of maybe the GFS is crying wolf. And perhaps it still is, but it's much less likely to be crying wolf now, because this afternoon's European model run has now shifted much closer to the GFS. Here it is At 3 days out, you can see a weak area of low pressure approaching the islands here, about to enter the Caribbean. And not as strong as the GFS once it enters the Caribbean. We saw the GFS already probably got a full-fledged hurricane by this point, but it does have what would probably be Tropical Storm Matthew by this point. And once it gets into the Caribbean, once it gets to about 65, 70 degrees west, it starts to go on the European. Here, as it passes by Aruba, it starts to gain intensity and then becomes a full-fledged hurricane once it gets to about 75 degrees west. And when it gets to this point, it begins to make a turn more toward the northwest. Here it is at day 9, down to 956 millibars, just slightly to the west of where the GFS had it. This is where the GFS had the major hurricane, a little bit stronger, brushing up against the south coast of Jamaica. And if you run it out to the day 10, that's all the European model will go out to. It's showing pretty much the same solution as the GFS, a major storm in the Western Caribbean. So this is one of the reasons to be concerned when you're looking at these models. And the other thing is, if I want to show you some about how much support the GFS has from its own package, this that I'm going into now is the ensemble package from the other day. When the GFS model runs, they run it again, and they run 21 ensembles, and where they run the model again. And usually, if you get half or 2/3 or 3/4 of them to support a solution, you know that it's a big signal. The other day, and this was a couple days ago, the GFS had all 21 models developed the storm. I have it counted here: 1, 2, 3, 4, 5. You can count them out. I put numbers next to all the little low pressure centers. Every single one of these models developed it. This was from a couple days ago, but I could take pretty much any run of the GFS in the last 2 days, and at least 20 of them of the 21 have developed it every single time. And like I said, some of them send it up the East Coast, some of them send it into the Yucatan, some send it into the Gulf. The details do not matter. What matters is that in the day 7 to 10 range, there is almost unanimous support from the GFS model that there's going to be something significant in the Caribbean by the end of next week. So that's number one. Number two is the ocean temperatures are just boiling. The second reason why we're concerned about this. These are the current sea surface temperatures, as you can see in the Western Atlantic, 30 degrees, once you get 29, 30 degrees Celsius, if you have a favorable upper air pattern without a lot of dry air, these hurricanes can go. And as you can see, we have that all across the Caribbean and into the Gulf and even into the Bahamas in case the storm would try to shoot one of the greater Antilles here, try to hop over them. So you've got that, but beyond that, you have something else. And you have something called the tropical cyclone heat potential, which is essentially measuring how deep the warm water is. This map you're looking at here shows how warm the water is at the surface. And while it is very, very warm, in some areas, it doesn't go down as deep as it does in other areas. And this map right here is really, really great because it shows you how deep the warm water runs, how much potential is there for an explosive storm. And as you can see, in the Western Caribbean, it is as large as it is any point in the Atlantic Basin. And in fact, it's larger than it is at any point deeper, than it is at any point on Earth. Even the Western Pacific as of right now. So you just have some explosive potential of a basin that can support a Category 4, Category 5 hurricane in this region. Number 3 is the MJO. This is a measure of it's essentially a wave that goes around the Earth. It shows you where you're likely to have rising motion around what parts of the Earth. The Western Caribbean and Gulf tends to correlate towards somewhere between the edge of Region 8 and Region 1 over here. And as you can see, all year long, this purple represents where the MJO was in August. The red here is where it was throughout most of the month of September. And these green and yellow lines are where it's supposed to go. And as you can see, all year long, we have not had the MJO over in Region 8 and Region 1, so it hasn't really supported a lot of rising motion, a lot of good low pressure areas for hurricanes to develop in this part of the world. But the GFS model and other models are starting to show that as we get out towards the end of this range, towards day 10, that may be changing. It may be going in this area, so you could have enhanced rising motion when the system gets into the Western Caribbean, which is, again, a red flag. Lastly, I want to do a little exercise, so I went through the history of the Atlantic, and I wanted to find the 12 storms that had the lowest pressure of all time in the Atlantic. Right now, this is what we have in recorded history. Obviously, this is going to be weighted more towards the last 50, 60 years because we don't have data once you go back beyond 50, 60 years, because unless the storm was making landfall, which we have a couple of those, but other than the ones that made landfall, the only way to be able to tell before that if it was in a ship, and if you were in a ship in a 900 millibar storm, you probably were not going to make it. But in any case, let's take a look at the 12 storms that we know of that had the lowest pressure here, going from the 12th strongest to the strongest. And let me blow this up a little bit here. The first on the list here is Hurricane Janet in 1955. This one went across the Caribbean and right into the Yucatan. At 11, we have Hurricane Ivan, became a Cat 5 3 different times, peaked in intensity just west of Jamaica. At number 10, we have the Cuba hurricane in 1924. It was measured at 910 millibars right here as it passed the eastern tip of Cuba. And we have Hurricane Dean, peak intensity right here as it nearly went into the Yucatan. Hurricane Mitch is on this list right here as it was just north of Honduras and Nicaragua. 2005 has a couple on here. Here's Katrina, of course, the famous one in the Central Gulf. We all know about her. Hurricane Camille, very, very similar spot to Hurricane Katrina, is on this list. Hurricane Allen, a little bit like Hurricane Ivan from 2004, became a Cat 5 3 times. Allen reached his peak potential right in this area here as he was just to the northeast side of the Yucatan Peninsula. Again, another one from 2005 here is Hurricane Rita, just a little bit south of where Katrina and Camille were when she reached her peak intensity, but this was, now we're in the sub-900 millibar club here. I believe that began with Allen over here. But and then we've got the Keys Hurricane, the Labor Day Hurricane 1935. We only know it was this low because, again, it hit land. When you go back this far, it was walloping the Keys. That's when it reached its low pressure point. And then we got Hurricane Gilbert, 1988, the original strongest hurricane of all time, but from 1988 to 2005 when it reached a pressure of 988 millibars right over here in the Western Caribbean. And then the strongest storm of all time in the Atlantic, at least that we've been able to measure at 882 millibars, Hurricane Wilma from 2005. So what I did, I looked at this, and I decided I plotted them on a map, and just to see what they look like. And this right here is what the map looks like. All the red X's are where the strongest hurricanes in the entire Atlantic basin is. So I'm looking at hurricanes, the 12 strongest hurricanes ever, anywhere in the Atlantic. And all of the hurricanes, what you notice about them, can be found in this circle right here. All 12 of them, the 12 strongest storms of all time, are all in this area. And this is why I find what the GFS and the European model are, the GFS consistently showing, and now the European has joined on board. This is why what they are showing is so concerning, because they're showing a major, major storm moving up toward this area in the day 9, day 10 range with unbelievable tropical cyclone heat potential, and an MJO heading towards the regions 8 and region 1, which supports this, and into an area that typically has the largest hurricanes in Atlantic history. I'm not saying that Hurricane Matthew is going to join that list, but I am saying that if you were going to create a scenario 8, 10 days out that had the potential to have a major, major, major storm, this is pretty much it. The table is set. The ducks are out on the pond. It is now just a matter of how do they line up. That's what we're going to have to watch over the next week. And we do have plenty of time to watch it, as it's going to take a long time to make its journey all the way across. But when you start taking what the models are showing, what the sea surface temperature looks like, what the trends are, and what the historical data says about where you can support big storms, boy, oh boy, I'm telling you, this is about as juicy of a threat as you can have this far out. Again, plenty of time to watch it. We'll see what it becomes. But Hurricane Matthew may become an infamous one on the list of hurricanes. It has a shot. So that's all for now. But I would certainly keep an eye on this one.